Hi, math students. Today, we're going to be working on our Algebra 2 final exam review for the 2021-2022 school year. All right, so the very first thing we're looking at is how to classify our polynomial equations. On the left-hand side, we see that we are classifying by the highest degree, and on the right-hand side, we're going to classify by the number of terms. So what I want to do is I would like to just go ahead and review each of these vocab words that are in our word bank, and then go ahead and fill in the information for the example equations that we have. So if we have a quadratic equation, we know that our highest degree is going to be a 2. So we're looking at an x squared. There's going to be nothing higher than an x squared there. A quartic equation, remember in the word quartic, we have the word quart, and we know there are 4 quarts in a gallon and 4 quarters to a dollar. So we know quart represents 4. So a quartic equation is an x to the 4th equation. Cubic is x cubed. We've kind of talked about how those are the cubic, cube, same thing there. Linear has the word line in it, and we know the ones that have a line is when it's just plain x, or technically x to the 1st, but we don't generally write to the 1st power. Quintic is x to the 5th. Now remember, when a mother has 5 babies at once, we call them quintuplets. So a quintic that has that same quin beginning there, a quintic equation is an x to the 5th, and then a constant is just going to be a number. There's not going to be a variable there. So those are our words classified by highest degree. So I'm going to go through here, and I'm going to go look at problem 1. We have an x to the 3rd, an x squared, an x, and then no x at all. So what's the highest little tiny exponent number here? That would be the 3. So we have an x to the 3rd as our highest. We know an x to the 3rd being the highest classifies this as a cubic equation. Looking at problem number 2, we have an x to the 4, an x, and a 10, or just a number there. We see the highest exponent is a 4. So an x to the 4th equation is a quartic. We write the word quart, I-C, quartic equation. In number 3, it's pretty easy because we only have one variable with an exponent, and that's an x to the 5th. So an x to the 5th is called a quintic, Q-U-I-N-T-I-C, a quintic equation. And then lastly, we have x minus 8. I see that my highest exponent, remember when there is none written, is to the 1st, which is a linear equation. So that's classifying our polynomial equations by their degrees. So now let's go ahead and classify them by the number of terms. So a monomial is when there is one term. Mono means one, so one term. A trinomial is when there are 3 terms. And let's think of other words that start with tri. We have our tricycle, a 3-wheeled bike there. And so we know the word tri stands for 3. Poly means many. So this is 4 or more terms. We're just going to refer to all of the one that has 4 or more as having many terms, a polynomial. And then lastly, we have a binomial. Bi means 2. So a binomial means there are 2 terms. So bifocals have 2 lenses. Bicycle has 2 wheels, right? So bi means 2. So let's count our number of terms here. We have 1, 2, 3, 4 terms here. So we refer to the first one as a polynomial. In the second one, we have 1, 2, 3 terms. 3 terms is a trinomial. For number 3, there's only 1 term, so we call it a monomial. And then, of course, in the last one, we have 1, 2 terms, so we call that a binomial. So this is problems 1 to 4. We classified the problems according to their highest degree and according to their number of terms. So make sure you take some time to study those vocabulary words so you know how to appropriately classify our polynomials on your final exam. All right, so I'm going to go ahead and clear that out. And I'm going to scroll down, so pause the video here if you need to. And we're going to scroll down so we can see problem number 5, which is all about our synthetic division. Okay, let's go ahead and do our synthetic division for this polynomial equation. We're being asked to evaluate the polynomial for f of 3. And we're going to use synthetic division to do so. So how do we set it up? Well, we look at the coefficients of our variables here. So the first number in front of x cubed is 2. In front of x squared is 4. In front of x is -10. Now remember that negative, the minus signs have to count as negatives in front of our coefficients. You have to include those. And then the last number here is -9. So we filled in our synthetic division. And now we have to put the number 3, f of 3, that's what we're evaluating, on our side little bar there. And we can begin the process. Now, the process is just a continual thing back and forth. So the first number, this is the one and only time we do this, that one comes straight down. We don't do anything to it. Once the number comes outside of the box, we multiply by the number that's on the outside on the sidebar over here. So 2 gets multiplied to 3 because 3 is the number on the sidebar over here. So 2 times 3 is 6. Then what do? We add straight down. 4 plus 6 is 10. A number came outside of our synthetic division box. So we take that number and we multiply by 3. So 10 times 3 is 30. Then what do? We add straight down. -10 plus 30 gives us 20. Now, 20 came outside the box. So we're going to multiply that by the number on the side over here by 3. So 20 times 3 is 60. Then we add straight down. -9 plus 60 is 51. And since 51 is the last number, 51 is the answer to our synthetic division. So you bring the first number straight down, multiply the outside number, add straight down, multiply the outside number, add straight down, multiply the outside number, add straight down, and you continue this process until you have now added each of the columns till you get to your final answer. Again, if you need to pause the video, please do so now. I'm going to clear this out and I'm going to scroll on down to page 2. All right, with page 2 here, this is kind of a large problem. I'm going to just reduce here, see if we can, oh, it's not going to work. I was going to see if we could fit the whole thing on the screen, but I don't think that's going to happen. So it's okay. We'll start out by first figuring out what our roots are and what the end behavior is for our polynomial, and then we'll just remember that information or write it down on a piece of paper, and we'll go ahead and sketch it below. So let's go ahead and do our synthetic division first. I'm going to do it a little quicker than we did in our last problem since we already did the process. We're going to write our coefficients. So the number in front of x cubed here is 1. The number that's in front of x squared here is 4. The number in front of x is -11. Remember those minuses count. And the number that's at the end here is -30. It tells us x equals 3 as a root. So we're going to put 3 on the side. And we're going to automatically write 3, 0 as our x-intercept. So we already have one of our x-intercepts because it gives it to us in the question to get us started. So again, bringing that first number straight down, multiplying by the outside number. So 1 times 3 is 3. Add straight down. 4 plus 3 is 7. 7 times 3 is 21. We're going to add straight down. -11 plus 21 is 10. We're going to multiply that by this outside number 3 here. 10 times 3 is 30. We add straight down and get 0. Now, remember when we're looking for our x-intercepts and you are given a root in the beginning of the question, you must get 0 on the end here. If you don't get 0 on the end, you did something incorrect because we need these 3 numbers and these 3 numbers only. These become our new equation. We started with an x cubed equation. 1 less than x cubed is x squared. So we have x squared plus 7x plus 10 as our new equation here. And then we go ahead and factor that. So we say, okay, what multiplies to 10? This is factoring our quadratics from earlier in the school year, right? So what multiplies to 10 and what adds to 7? And I hope you were able to say 5 and 2. So we write x plus 5, x plus 2. And with those 2 equations, we set them equal to 0 to get our 2 remaining x-intercepts. So x plus 5 equaling 0, we subtract 5 from both sides. So we get x equals -5. So that's our next x-intercept, -5, 0. And then we solve for x on the second equation by subtracting 2. So we get x equals -2. So -2, 0 is our final x-intercept. So we have our 3 x-intercepts. Those are going to be the dots that we create on the x-axis on our graph when we go ahead and scroll down. So we look here. Now we need to know the highest degree. Is that an even or an odd number? So we look here, x cubed, that's a 3. 3 is an odd number. What does that tell us about our end behavior? That tells us that they're going to go in opposite directions. If the right-hand side goes up, the left-hand side goes down. If the right-hand side goes down, the left-hand side goes up. So we know that we're going to have opposites here for 9 and 10. The leading coefficient, meaning the number in front of x, is positive. There's no negative sign there, so it's positive. So now that we know that it's odd and positive, we know the right-hand side is going to go up and the left-hand side is going to go down. Just off to the side here, I'm just going to draw a little refresher for you all and hopefully remember. So if it's odd, we'll do the one we just did. If it's odd and positive, positive, pop. Odd and positive, we know the right-hand side is going to go up and the left-hand side is going to go down. If it was odd, so like 1, 3, 5, 7, 9, so on and so forth, and negative, so it was a negative number right out front here, the right-hand side would be going down and the left-hand side goes up. And I'm going to go to the other side here and I'm going to talk about the evens. So if it was even, like x squared or x to the 4th or x to the 6th, so on and so forth, and it was positive, then we know the right-hand side goes up and the left-hand side goes up. So even makes them be the same. They're going to match. So if it was even and negative, so if there was a negative sign in front of that x squared, so negative x squared, negative x to the 4th, so on and so forth, then the right-hand side is going down and the left-hand side is also going down because if it's even, they go in the same direction. So we have information here. So our three pieces of information we need to remember. We need to remember our x-intercepts. We need to know that the right-hand side is going up and we need to know that the left-hand side is going up. So 3, -5, -2, up and then down. So I'm going to clear that out. We're going to scroll on down to our graph here. We're going to put dots at 3, -5, and -2. The furthest most right, the right-hand side was going up. So from the furthest most right point, draw an arrow that's going up to the upper right-hand corner. The left-hand side's going down. So the furthest most left point, draw a line going down to the left. And then we weave in and out of our points. Again, we're just sketching, so we're not worried about how high or how low we're going. And that is a sketch of our polynomial equation. You can go ahead and pause the video here if you need to. I'm going to go ahead and clear this out and we'll move on to the next page. Okay, so our whole next section, we just got done our polynomials. We're going to focus in on our rational expressions here. We're going to look at simplifying, multiplying, dividing, adding, and subtracting. So for this first one, number 12, we are going to simplify this. And the way we simplify this is by factoring the quadratic. So how do we factor again? When there's nothing in front of x squared, we could just simply say what multiplies to the last number and adds to the middle number. So we need two numbers that multiply to 18. So if you need to off to the side, say, okay, to get 18, I know 1 times 18 gives me 18, 2 times 9 gives me 18, 3 times 6 gives me 18, and that's it. So which of these pairs would add to give you 9? Well, 1 plus 18 is 19, 2 plus 9 is 11, 3 plus 6 is 9. That's the pair we want, right? Because if we multiplied them to 3 times 6, we'd get 18. If we added them, 3 plus 6, we get 9. So we can factor that out to be x plus 3, x plus 6. So we factored out the numerator of our fraction here. So the bottom is x plus 3, or sorry, x plus 6. We didn't have to do anything to that. We're going to cancel the x plus 6 on top with the x plus 6 on bottom, and we're left with x plus 3 as our final answer for problem number 12. In problem 13, we're multiplying our quadratics, and really all that is doing is just adding more factoring to it. So we just did x squared plus 9x plus 18. That factored out. We already did that. X plus 3, x plus 6. That was literally the one we just did above. So let's use our resources and save ourselves some time. Then there's the x plus 3 on bottom. That's being multiplied to. On the top, we have x plus 4. That's not factorable. It's not an x squared equation. But now we have to factor the bottom. So we have to say what multiplies to 30 and adds to 11. So let's make a list over here. Numbers that multiply to 30 are 1 times 30. We could say 2 times 15. We could say 3 times 10. 4 does not go into it. 5 times 6. So these are all of the numbers that multiply to 30. So which pair adds to 11? 5 plus 6 gives us 11, right? So we can say x plus 5, x plus 6. And then we're going to cancel out what we have in common here. So I have an x plus 6 on top. I have an x plus 6 on bottom. I have an x plus 3 on top. I have an x plus 3 on bottom. So what's left is an x plus 4 on top and an x plus 5 on bottom. And that's your final answer. All right. The next one is division. And remember, with division, we have to change that to multiplication and then flip the second fraction. Okay, so let's factor the top. We say what multiplies to 20 and adds to 9. So you can list all your factors of 20. 1 times 20, 2 times 10, 3 doesn't go in, 4 times 5. So which of these pairs adds to 9? If you said 4 and 5, you are correct. Then we have the x plus 5 on the bottom. Changing the division to multiplication, that's critical there. And I'm going to flip it. So this x plus 11 that was on the bottom now goes on top. And we factor this, what multiplies to 24 and adds to 10. So the two numbers that multiply to 24 are 1 times 24, 2 times 12, 3 times 8, 4 times 6. And which of these pairs adds to 10? That's the 4 and the 6. So we can write x plus 4, x plus 6 here on the bottom. Notice we flip-flopped this. That's critical. That's crucial. Make sure you're paying attention to that. So I have an x plus 4 on top and an x plus 4 on bottom. I have an x plus 5 on top and an x plus 5 on bottom. Nothing else is the same, top to bottom. So we write x plus 11 on top, x plus 6 on bottom, and that's our final answer for number 14. So I want you to go ahead and take a minute, and I would like for you to pause the video if you need to, rewind it, rewatch it, do what you need to do in order to just refresh your memory on how to simplify, multiply, and divide our rational expressions. And then you can go ahead and scroll down. All right, so for number 15 and 16, we're adding and subtracting. Now remember, when you add and subtract, fractions, you need to have a common denominator, meaning the bottom of this fraction needs to be the same. So these are the same. We have an 8x on the bottom of the left. We have an 8x on the bottom of the right. We don't need to do anything to make them be the same. So now we just simply treat the top as if the bottom didn't exist there. So we have 7x plus 13 minus, now remember, everything changes its sign after a minus sign. So minus 4x minus 8. It's not plus 8, it's minus 8. Everything behind that minus sign changes its sign. So now we collect our like terms here. So we've got 7x and minus 4x. 7x minus 4x is 3x. And then we have 13 minus 8, and that gives us 5. Okay, so our final answer here is 3x plus 5 over our common denominator, 8x. Now, why can't I cancel out these x's here? Remember that the 3x plus 5 is connected with that plus sign. So that's one whole piece. So we can't cancel out the x's because they are not identical. For number 16, we have to add these two fractions, but notice that our denominators, they are not the same, and we need to make them the same. So on the left denominator, we have an x plus 2. So we're going to put an x plus 2 on the right-hand side so it matches. And whatever we do on bottom, we must also do on top. On the right-hand side, we had an x plus 1. So I need to put an x plus 1 on the left-hand side so that it matches. And whatever we do on bottom, we must also do on top. And remember, when there's a number there, we have to distribute that number into the parentheses that we just created. So the top of the left-hand side becomes 7x plus 7 over that common denominator, x plus 1, x plus 2. And that's being added to, multiply the 3 through the parentheses. So 3 times x is 3x, and 3 times 2 is 6. And that's over the common denominator, x plus 1, x plus 2. So now we have a common denominator. These are the same. This matches this, they match. So now we can just add the top. So we would say 7x plus 7 plus 3x plus 6. Notice we didn't have to change the signs on the second equation because it was a plus sign, not a minus sign. So we're going to collect those like terms here. We have 7x plus 3x. That's going to give us 10x. And then we have our 7 plus 6. That's going to give us 13. So our final answer here is 10x plus 13 over x plus 1 times x plus 2. So that's our final answer. Okay, so problem number 17 wants us to solve the rational equation through cross multiplication. So remember, cross multiplication is when we multiply the top left to the bottom right. So that's going to give us 11 times x plus 3. So that 11 has to get distributed through. And then we take the bottom left and we multiply it to the top right. So we're just going diagonally. We're making a cross diagonally across. So that's going to be equal to x times 8 or 8x. So let's go ahead and distribute that 11. So 11 times x is 11x, and 11 times 3 is 33. That 11 has to go to both items. That's equal to 8x. Here's my equal sign. I need to make sure that my x's are combined. So I'm going to subtract the left-hand x to the right-hand x. So 8 minus 11 is negative 3. So we get 33 equals negative 3x. Divide both sides by negative 3 because we're trying to isolate the x here. So we get x is equal to negative 11 as our final answer. Okay, so I'm going to clear that page out. Pause the video here if you need to. And then we're going to continue on to the next page. About halfway done here. Moving on to our radicals. All right, simplifying radicals. I know we love simplifying radicals. It can be nice and easy. First one, square root of 25, that's a perfect square. We know that's 5. That's pretty simple, straightforward. Square root of 45 is not a perfect square. So we need to try and simplify this by coming up with two numbers that multiply to 45. So I think of 9 and 5. Now remember, you can pick any two numbers that multiply to the number underneath of the root, and you just keep breaking it down until you have all prime numbers. So 9 is 3 times 3, and 3s are prime, 5 is prime. So these are all of our numbers that we're dealing with. So there are two 3s. So that means there's one 3 on the outside. There's only one 5, so that 5 stays on the inside. So square root of 45 reduces down to be 3 root 5. For 20, we have to reduce our variable inside of our root, and I absolutely love doing these because I think it's so clean and simple here. So we write out as many x's as we have. So this is x to the 7th, so I'm going to write out 7 x's. So 1, 2, 3, 4, 5, 6, 7. And now it's a square root. Now remember, a square root's like a little tiny 2 there we don't write. So we're going to circle these in groups of 2. So this is a group of 2. Here's a group of 2. Here's a group of 2. So we have one x on the outside, another x on the outside, and another x on the outside. So 3 x's on the outside. But this poor x didn't have a buddy, so he remains inside of the root. So x, square root of x to the 7th becomes x to the 3rd square root of x when it's all simplified out. For number 21, we have a number and a root, and a variable, right? So we're going to just do those separately. We can do those, the square root of 27, same thing as we did for number 19. We say two numbers that multiply to 27. I say that's 9 and 3. 9 becomes 3 and 3. Here's a pair of 3s, so we say 3 on the outside. This 3 is single, so 3 stays on the inside. So when we simplify the square root of 27, we have 3 root 3. Now let's do x cubed. So we've got x, 3 x's because it's x cubed. I notice that there is a pair, one pair, so that means that one's going to go on the outside and then one remaining, so that's going to stay on the inside. So let's write our final answer here. We have a 3 and an x on the outside, and we have a 3 and an x on the inside. And that's your final answer, 3x root 3x. All right, so I'm going to go ahead and clear that out. I'm going to scroll down. We're going to get to problems 22 and 23 here. Just doing more with our roots. Yes, I can scroll down so we get 24 and 25 to fit into. All right, so 22 and 23 is multiplying and dividing our radicals. So if we're multiplying 10 and 8, that gives us the square root of 80. And we want to make sure we simplify that. We just simplified it by 10 and 8, but we're going to do our factor tree anyway. 10 is 5 times 2. 8 is 2 times 4, and then 4 is 2 times 2. So because there's a lot of numbers here, I'm just going to cross off what we split. We split 80, we split 10, we split 8, and we split 4. So our remaining numbers here are our 2's and our 5. So here's a pair of 2's, here's a pair of 2's, and here's our 5. So that means there's a 2 on the outside, another 2 on the outside, and a 5 on the inside. So 2 times 2 is 4. And then the 5 on the inside. So 4 root 5 is our final answer here. For number 23, let's look at our numbers and our variables separately here. We have 24 being divided by 6. Remember that when you're dividing two square roots, you can put them underneath of one square root. So 24 divided by 6 is 4. That's still underneath of the square root. And we know the square root of 4 is a perfect square, which gives us 2. And now let's move on to our variables. We have x to the 7th, so 1, 2, 3, 4, 5, 6, 7 x's over x to the 3rd, 1, 2, 3 x's. We're going to cross out an x from the top and the bottom till we run out. How many do we have left? 1, 2, 3, 4 x's. So we have x to the 4th, or 4 x's on the outside. on the inside. We circle them in groups of 2. So we have an x squared on the outside. So our final answer here is 2x squared. All right, for number 24, we are subtracting 13 root 5 minus 9 root 5. We notice that the roots are the same. When your roots are the same, you just simply do the subtraction of the numbers in front of your roots. So 13 minus 9 is 4. So we get 4 root 5. Just write it down. 13 minus 9 equals 4. So we get 4, and then the root that we have in common, root 5. Notice we didn't do root 5 minus root 5 is 0 and get rid of the root. We also didn't do root 5 plus root 5 or double the root 5 or anything of that nature. When the roots are the same, it's simply like putting in x there. 13x minus 9x would give us 4x. So the root 5 stays the same. For number 25, we see we have the square root of 8 plus 9 root 2. We notice the roots are two different numbers. So what I'm going to do is I'm going to reduce down the square root of 8 so that maybe we would have the same root. So we have 8 became 4 times 2 and 4 became 2 times 2. So we have a pair of 2s. So there's a 2 on the outside. This poor 2 does not have a buddy, so that stays on the inside. So we have 2 root 2. And then we're going to bring down this 9 root 2, so plus 9 root 2. And now please note that we have a root 2 and a root 2. So we can just add these numbers in front. 2 plus 9 is 11. And then we keep that same root, root 2. So root 8 plus 9 root 2 is 11 root 2. You can go ahead and pause the video right now if you need to. I'm going to go ahead and clear out the information. And we're going to scroll down and move on to solving our radical equations and some of our exponent rules. Let's just start with solving our radicals. Remember, when we're solving an equation, we're trying to isolate our x. We're trying to get our x by itself. So we think of our opposite or inverse operation. So the opposite of addition is subtraction. The opposite of multiplication is division. The opposite of a root is squaring it. So our steps to solving for a root, it's very important to remember that to get rid of a root, you have to square it, but you have to get rid of anything that's in front or behind the root first. So there's nothing on the same side of this root other than the 9x, and that's inside the root. So we're going to cancel out that root by squaring it. So now the root and the squared, they're gone, and we're left with 9x. Whatever we do on one side of an equation, we must do on the other. So I put a little tiny squared on the left-hand side. So I put a little tiny squared on the right-hand side. 6 squared is 36. And now this just becomes a simple solve for x equation that you've done for years. If I have 9x equaling 36 and I want 9 by itself, we do the opposite operation of what is being performed to the x. So 9 is multiplying to x. We divide by 9. 36 divided by 9 is equal to 4. So x is equal to 4. Let's look at problem number 27 here. Problem number 27 is again another root problem, but notice we have this 3 in front of the root first. And remember what I said with the previous problem, we need to remove anything that's in front of or behind the root first, not anything that's under the root. So 3 is multiplying to the root, so we're going to divide both sides by 3 first. So we get the square root of x plus 7. The square root didn't disappear. We didn't do anything to get rid of that square root yet. We simply removed the 3 that's in front of it. 9 divided by 3 is 3. Now we can get rid of that root. Now we can cancel out the square root with squared, right? That's going to cancel. The square root and the squared cancel. And whatever we do on one side, we do on the other. So since I wrote a little squared over here, I'm going to write a squared over here. What's left is the x plus 7, and that's equal to 3 squared, which is 9. Then we solve for x. If I have x plus 7 equaling 9, I'm going to subtract 7 from both sides. So we get x is equal to 2 as our final answer. Now I know we can see problems 28 and 29, but I'm going to clear out 26 and 27 and just scroll down because we're just discussing a lot of exponential properties in the next few problems. I want to see if I can get them all to fit on the same screen. So if you need to pause this video now, go ahead and pause the video. And I'm clearing it out and scrolling on so we can see our exponential properties. Get as high as I can. There we go. Okay, so these next 6 problems are exponential properties, just a variety of them. So I just want to kind of go over all of our properties so that we can remember them for the final exam. So the first property that we have exemplified here is a 22 to the 0 power. And we remember that anything, I'm writing this down, maybe you should too, to the 0 power is 1. So 22 to the 0 power became 1. Now, did anything happen to the 19? No, 19 didn't have any exponent. Not, oops, I wrote 12 there. Erase that out. That wasn't to the 0 power, so we just bring the 19 straight down. So 19 times 1 is 19. So our final answer for number 28 is 19. Number 29, we're practicing our negative exponents. So remember, if you have a negative exponent, that means the base and its exponent are unhappy where it is. So if you have a negative exponent and a base in the numerator, in the top of the function, and on the top of the fraction, you want to move it to the denominator or the bottom. If you have a negative exponent in the bottom or the denominator of your fraction, you want to move it to the top. So looking specifically at this a to the -2 that's on the top of the fraction, that's unhappy being on top. So we're going to move it to the bottom. So I'm going to draw my fraction bar and I'm going to draw that a to the 2 on bottom. And remember that once we move it from the top to the bottom or from the bottom to the top, that negative exponent becomes positive. Now let's look at the second part here. We have a b to the -5. B to the -5 is in the bottom of your fraction, and it's got a negative exponent. That means it's unhappy being in the bottom of your fraction. So we're going to move it to the top. And then once we move its location, that negative exponent becomes positive. So our final answer here is b to the 5th divided by a squared. All right, looking at problem number 30 here, we are multiplying like bases. What does that mean? The number that holds the exponent is your base. So the number that's holding our exponent 3 here, or the variable that's holding our exponent 3 here is y. The number that's holding our exponent 9 here is y. So these bases are the same. They're both y's. So when you multiply bases that are the same, you add those exponents. So we say 3 plus 9 is equal to 12. So we get y to the 12th power for this problem. In that same vein, if we divide like bases, we subtract the top exponent minus the bottom exponent. So in this case, we have d as the base in the numerator and d as the base in the denominator. They are the same base that is dividing. So we can say d to the top exponent minus the bottom exponent. 11 minus 6 is 5, so we get d to the 5th power. Moving on to problems 32 and 33, we have a power to a power here. So we have m to the 11 to the 8th. We have a power to a power. We multiply those exponents when that happens. So 11 times 8 is 88. So we have m to the 88th power. For number 33, we have 6x to the 8th to the 4th. Now remember, when we have more than one piece inside of parentheses with the exponent outside the parentheses, that exponent has to go to both the number or whatever number of variables that we have here. So that makes it a 6 to the 4th and an x to the 8th to the 4th. So let's do our 6 to the 4th. Remember, the exponent tells us how many times we multiply a base by itself. So we're doing 6 times 6 times 6 times 6. So 6 to the 4th power is 1,296. And then the x to the 8th to the 4th, we have a power to a power here. We just simply multiply the 8 times the 4. 8 times 4 is 32. So we get x to the 32. So 6x to the 8th to the 4th power, when it's all reduced out, is 1,296, x to the 32nd power. All right, so I'm going to clear out these properties of exponents. You can pause the video here if you need to, clearing it out. Okay, so our next two problems are on exponential growth and exponential decay equations. I'm just going to do a brief review of that on the side here. So remember that your exponential growth formula is going to be a times 1 plus r to the t. Remember, your a is your initial amount. Your r is your rate. your rate in terms of a decimal. So when we're given the rate in a percent, you need to make sure that you're turning that to a decimal. And t is your time, okay? And then your exponential decay formula is a times 1 minus r to the t. So the only difference between these two formulas is that between these is a plus and between these is a minus. So that's pretty critical information there, right? So that being said, just clearing that out there. The a, the r, the t is all the same between your growth and your decay formula. So let's go ahead and do 34. It says, suppose you deposit $5,000 in a college fund that pays an interest rate of 5% per year. We're going to write an exponential growth function to model the situation. And we want to know how much money will be in the account after 12 years. And I picked 12 years because I thought, hey, 12 years in school. So if you start out with $5,000, how much are you going to have in the end after your 12 years of schooling with a 5% interest rate? So let's check this out. So you started with $5,000. So the initial amount, that A there is 5,000. So we say times the quantity 1 plus the rate as a decimal. So your rate is 5%. So we need to take that 5% and we need to change it to a decimal. Remember what I said, nice and easy. Take the decimal, decimals after 5, and move it to the left 1, 2 spaces. And to fill in that empty space, you put a 0. So 5% is equal to 0.05. So we say 1 plus 0.05. And then you can put that to the t, and that's your equation. But we are solving for part B. We want to know how much money is going to be in the account after 12 years. So I'm going to throw a 12 in there. So let's solve this down. So we have 5,000, part B, we're solving it, 5,000 times 1 plus 0.05 to the 12th. We do our PEMDAS. Please excuse my dear Aunt Sally. The P stands for parentheses. So we need to solve what's in parentheses first. So we say 5,000 times 1 plus 0.05 is 1.05, and that is to the 12th power. So we're done with our parentheses. We solve the parentheses. Now we have to do our E, which stands for exponent. So that means I have to do the base with the exponent and solve that next. Now remember, I'm just going to do this off to the side here. Remember how I said we do this on our iPhones? We have that X to the Y button. So we type the base 1.05, then you hit the X to the Y button, and then we type the exponent, which in this case is 12. Now, both iPhones and Androids, they have that X to the Y button. You need to make sure you turn your phone sideways so that your calculator becomes a little bit bigger with a lot more button options. And then you're going to find that X to the Y button there. So we have the $5,000 was our initial amount, right? And we're multiplying that to 1.05 to the 12th power. When you plug that into your calculator, you have 0.737. Oops, I'm sorry. I wrote the wrong one down. Sorry about that. 1.05 to the 12th power is actually 1.79, and then it was 5, 8, blah, 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 blah. So we're going to round that 5 up to a 6. And then we take that 5,000 and times it by 1.796, and we get $8,980 in the account after 12 years. Okay, let's go ahead and do number 35. We have a town population of 90,000 decreasing at a rate of 3% each year. So we're going to write an exponential decay problem. So we were going to write our initial amount, 90,000. We're going to multiply that by 1 minus the rate. So the rate is 3%. So we want to take that 3%, we want to turn it to a decimal. So we want to move the decimal to the left 2 spaces. So 3% gives us 0.03 as a decimal. So 1 minus 0.03. And then you could do that to the t, because that'll give you your formula and you'll be able to calculate the population at any year. But we are not going to do to the t. We want to know specifically, part B wants to know, what is it after 10 years? So we're going to take that 90,000. And we're going to say 1 minus 0.03 to the 10th power. We do, again, our PEMDAS, we start with our P, which is our parentheses. So 1 minus 0.03 is 0.97. That's to the 10th power. Then we say 90,000 times 0.97 to the 10th power. We do our exponent next, right? And that is 0.737. That's the decimal that I accidentally wrote above. So 90,000 times 0.737 gives us 66,330. So in 10 years, the population has dropped to 66,330 people left in the town. All right, so I'm going to go ahead and clear that out, and we're going to move on to our exponential equations. We like solving for x when it's in the exponent. So number 36. Now, these are my last 4 problems here. We have 6 to the 7x plus 3 equaling 6 to the 5x plus 11. When your bases, the bases are the ones that hold the exponents, when those bases are the same, you simply set the exponents equal to each other. So 7x plus 3 equaling 5x plus 11, and we solve. So I need to bring my x's together. So I subtract 5x from both sides. So we get 2x plus 3 equals 11. Subtract 3 from both sides. 11 minus 3 is 8. So we have 2x equals 8. Divide both sides by 2. Coming right up here. 8 divided by 2 is 4. So we get x equals 4 as our final answer for number 36. For number 37, we see we have base 12 and base 1, and we need them to be the same. Now remember when we learned this just last week, we talked about when we have a number 1, it's to the 0 power. So we have 12 to the x minus 10 equaling 12 to the 0 power. Now the bases are the same. Now we can set those equal. So I have x minus 10 equaling 0. To solve for x, I'm going to add 10 to both sides. So we get x equals 10. All right, our last 2 problems, we need to find those common bases. So we have a 2 to the x plus 8, and we have a 16. So we need to know 2 to the what would give me 16. Well, 2 to the 0 is 1. 2 to the first is 2. 2 to the second is 4. 2 to the third is 8. 2 to the fourth is 16. So I can change 16 to become 2 to the fourth. So we have 2 to the x plus 8 equaling 2 to the fourth. My bases are the same. So we get x plus 8 equals 4. I'm going to subtract 8 from both sides. So we get x is equal to -4 for problem number 38. All right, and 39, we want to make those bases be the same. So I'm going to see if I can change 27 to base 3. So I'm going to say 3 to the 0 is 1, 3 to the first is 3, 3 to the second is 9, 3 to the third is 27. So I can change that 27 to be a 3 to the third. Now remember, 27 was to the x, so 3 to the third must also be to the x. And then rewriting the right-hand side, x plus 8. So when we have a power to a power, we multiply these. So we get 3 to the 3x equals 3 to the x plus 8. We can set those exponents equal to each other now. 3x equals x plus 8. Subtract x from both sides. So we have 2x equals 8. Divide both sides by 2. So we get x is equal to 4 for problem number 39. And that, ladies and gents, is everything that we have covered the second half of our year in Algebra 2. Make sure you please take the time to study this review. It's very important that you take the time to do that so that you are prepared walking into your final exam. And good luck.